Hello and welcome to this automotive technology video. My name is Nick Dimitrakopoulos and today we will talk about mode conversion test for MDI test heads for automotive Ethernet. For this reason, I have invited my colleague and our expert in this field, Jorn Pfeiffer.
Hello, Nick.
Jorn, hi, and thanks for joining me in this video. Can you please tell me what have you prepared for us today?
Yeah, I prepared a vector network analyzer to make mode conversion measurements on MDI test heads.
Okay, so let's have a look on the setup. So, Jorn, what is a mode conversion for somebody who does not know?
Yeah, the mode conversion characterizes if a fixture that's used is converting the differential input signal into a common mode signal, and that's what we don't want. So if it's properly designed, you will have a very, very low mode conversion behavior of the test head.
So I see these MDI test heads have two ports, so I guess a two-port vector analyzer is needed for such kind of measurement?
Yes, in this case we only make differential or mixed mode reflection measurements, so we need only a two-port device.
Okay, and of course the specification have some VNA settings that we need to follow, so let's have a look on this. Okay, so what is the very first thing that we need to do before making those measurements?
So here with the mode conversion measurements, it's very important to have a very precise calibration. So we start here with calibrating the instrument with a manual calibration kit. So I now need to go through all the measurements done for a manual calibration. Okay, so now I've done all the single measurements of the calibration process and I click Apply Now. And what you see now is the calibration accuracy of the VNA. So to measure very low mode conversion values of fixtures, first the VNA calibration needs to have a very low mode conversion value. So what you now see is the live measurement, the first measurement after calibration. You see the measurement trace here is below 80 dB. In the higher frequency range, it somehow rises a little bit. But you see, the calibration is very accurate, and so we stay almost 15, somehow like 15 dB below the limit line. So the calibration is very precise, and we can use this to characterize the test heads.
So, Jorn, these test heads are mentioned in the Open Alliance TC8, which is for the ECU measurements, but actually the specifications comes from the TC9 Open Alliance for UTP. I knew that there was the version 2.0 with very stringent limit lines, but very recently the version 3.0 was released. Can you comment on that? Has something changed in the limit lines?
Yes, the lower frequency value relaxed from 69 dB to 61 dB. So it's somehow a little bit easier now to pass the test for the fixture balance.
So I guess now we are ready to connect the test heads and have a look on the performance.
Yes. So now I connect the MDI test heads. The first one is a Rosenberger MDI test head. So the measurement is done with only 100 Hertz of IF bandwidth. So it takes some time to measure all the points from the measurement sweep. But you see now it's already done here, and you see as well this fixture is very well designed. So the mode conversion of this MDI test head or fixture is very good, and it stays as well like 15 dB below the limit line. Now we show another example. We have now here ZF7A test fixture from Rohde and Schwarz, and you see it stays below the limit, so you can connect here any kind of connector you want to this fixture.
Jörn, thank you very much for this very nice and interesting demo. Can you please tell us, this is my last question, what kind of configuration somebody needs with a ZNB in order to be able to perform such measurements?
If you only want to do these TC8 measurements, you only need reflection measurements. So a 2-point device would be enough. And you will need a calibration kit and very phase-stable cables. And you can use what's recommended, a manual calibration kit. And you can alternatively use a calibration unit, but I would recommend the manual calibration because there the mode conversion after calibration will be lower.
Great. Jörn, that was very useful and helpful also for me. Thank you very much for joining me in this video. So, on behalf of myself and Jörn Pfeiffer, thank you very much. Please don't forget to go to our Automotive Ethernet Solution website for more cool videos and application notes. I will see you next time. Until then, stay safe and healthy. Goodbye.
Bye-bye.